Okay, we are looking at 12-1 on page 300 today. Understanding ratios. We're also going to be looking at 12-2. So, what is, right here, a mathematical way to compare quantities? Tom's Pet Service takes care of cats and dogs. Currently, there are more dogs than cats. Compare the number of cats to the number of dogs. Then compare the number of cats to the total number of pets at Tom's Pet Service. So here we see there are 14 cats, 17 dogs, and if you added them together, you would have, looks like 31 pets total. Okay, so that's your whole altogether, 31 pets, and right now they have 14 cats and 17 dogs. All right, let's look at the next page. All right, so here's a definition for you to write down. Ratio. A ratio is a relationship where for every X units of one quantity, there are Y units of another quantity. So make sure you get that definition down. Pause me if you have to. It says a ratio can be written three ways. All right, and we've talked about this before. X to Y, X colon Y, or X over Y. Now, whatever units they give first becomes X units, or the first unit that you would write, or the top unit here when they write it like a fraction. And then the second units becomes like Y here would be second, or on bottom in the denominator. The quantities X and Y in a ratio are called terms, another vocab for you to write down. So you use a ratio to compare the number of cats to dogs. So here we have 14 to 17 because there are 14 cats to 17 dogs, and notice they say cats first, so that's the number you put first. You always put it in the order that is asked. Or 14 colon 17 or 14 over 17. This ratio compares one part to another part. So let's look at the next here. So in the first example here, they're comparing cats to dogs, or part of the whole to another part of the whole, because the whole would be all the animals together. The second example here, it says use the ratio to compare the number of cats to the total number of pets, which would be the whole. So this is comparing a part to a whole, which is what we always see in fractions. So if we were comparing cats to the whole total number of pets, you'd have 14 to 31, 14 colon 31, or 14 over 31. Okay, so you can see how this would be, the first one would be part to part, and the second one is part to whole. All right, pause me and do number 1, 2, and 3. It says a 6th grade basketball team has 3 centers, 5 forwards, and 6 guards. Write a ratio for each comparison in 3 different ways. So all 3 different ways you can write a ratio. They want you to do that. Now remember, it's the basketball team that we're talking about here, and if I wanted to know all of the players in the basketball team, I would add 6 and 5 is 11 plus 3 more would give me 14 players total. So that would be my whole if I needed that. So go ahead and pause me and do 1, 2, and 3 and push play when you're ready to check. So forwards to guards, well, forwards to guards could be written as 5 colon 6, 5 to 6, or 5 over 6. Remember, I write it exactly the order that they ask for it. Number 2, centers to total. Centers, well, I have 3 centers, so 3 colon to my 14 whole players, so this is a part to whole. 3 to 14, or 3 over 14. Number 3 is centers to guards, so this is part of the team to part of the team, or part to part, which would be 3 to 6, 3 to 6, and then 3 over 6, which I would probably go ahead and make 1 to 2. All right, do you understand number 4? It asks, what are two different types of comparisons a ratio can be used to make, and how's this different from a fraction? Well, ratios can compare two numbers, and we have said that they can compare part to part, here, or part to whole. Now, not going to get it all on there. How's this different from a fraction? Well, when we think of fractions like 1/6, we're always talking about part to whole. We're saying, well, how many does it take to make a whole? Well, 6. And how many pieces do we have? 1. So in fractions, this is why it's somewhat different. In a fraction, we're always talking about part to whole. Where in a ratio, we can be talking about part to whole, or the opposite, whole to part. I'd like you to pause me, do number 5 for the WISC homework, but we're going to continue on, so pause me and move on to 12-2. Alright, turn to page 302 and let's look at 12-2, equal ratios and proportions. How can you find equal ratios? The ratio of the number of basketball players, here we go, basketball players, to the number of baseball players at Grove School is 16 to 48. So notice they have basketball players first, 16, that's why 16's first, and then baseball players second. One way to write this term, the terms of this ratio, remember the numbers are called terms, is 16 over 48. And you can use what you know about fractions to find equal ratios and to write a ratio in simplest form. So this is kind of review for you. Okay, here's one way to find an equal ratio. Use multiplication, just like we did when we were finding equivalent fractions. You can multiply both terms by the same non-zero number. For example, so here they have 16 over 48, and they multiply both the numerator, 16, or the term, I should say, 16 by 3 to get 48, and they multiply then, of course, 48 by 3 also to get 144. So, if I said 16 over 48 was a fraction, I would say 48 over 144 is an equivalent fraction. Since it's a ratio, I will say this is an equal ratio. So 16/48 and 48 over 144 are equal ratio. So a mathematical statement that two ratios are equal is called a proportion. Make sure you get this down as a vocab, because we'll be talking more about proportions. So when two ratios are equal, it's called a proportion. All right, another way is just to use division. If it is possible, if both terms are divisible by the same non-zero number, you can divide them. So 16 and 48 are both even numbers and are divisible by 2. So they divide 16 by 2 to get 8, 48 by 2 to get 24. So 16 over 48 and 8 over 24 are equal ratios also. You can divide the terms by their greatest common factor and write the ratio in simplest form, just like we did with fractions. So we could also divide 16 over 48 by 16 and get 1/3. So 16 over 48, 8 over 24, and 1 over 3 are all equal ratios. Okay, we're looking at another example here on page 302. So how can you decide whether two ratios form a proportion? Okay, so here are some steps to help you decide whether each pair of ratios shown form a proportion. So we have two sets here. We have this set, and then we have this set we're going to look at. Here we have 7 laps over on this side, 7 laps in 14 minutes, and we have 12 laps in 24 minutes. Over here we have 16 shots, 12 baskets. Here we have 6 shots and 4 baskets. So the first thing you want to do is compare the units to see if they're the same across the top and the bottom. So our top units should, if I have laps up top, then I should have laps up top in my other ratio. If I have minutes on the bottom, then I should have minutes on the bottom of both ratios for them to be a proportion. Same thing over here. If I have shots on the top, they both should have shots on top and the number of baskets on the bottom. So here, both units are the same, so looking good so far. All right, the next step they show you, they say, well, write each ratio in simplest form, divide by the greatest common factor, or divide till you get it in simplest form. So here we have 14 over 7. They divide both by 7 to get 1/2. And then we're going to look at the next ratio, 12 over 24. They divide both by 12 and they get 1/2. So because both equal 1/2, these two ratios are proportional. Up here at the top, these ratios are proportional, so they form a proportion. All right, so now we're looking at shots per basket here. So we're going to write these in simplest form. They have 16 and 12. They divide both by 4, and they get 4/3. They have 6 over 4. They divide both by 2, and they get 3/2. So these two are not equal, so the ratios are not proportional. This does not form a proportion. All right, let's look at it, explain it here. What is always true about the simplest forms of two ratios that are proportional? So if two ratios are proportional and they're in their simplest forms, then the simplest forms of these two ratios will be the same, like these two up above here. Okay, they're always going to be the same. Now, if the ratio of girls to boys in a class is 4 to 5, does that mean there's exactly 4 girls and 5 boys in the class? No. That could mean that there are 8 girls and 10 boys in the class, because remember, this could be in its simplest form. So if I multiplied each by 2, I could have 8 girls and 10 boys. Or if I multiplied by 3, I could have 12 girls and 15 boys. So that doesn't always mean that that's exactly the number of girls or exactly the number of boys. All right, for homework, I'd like you to go ahead and make sure you did number 5 on 12-1 and do 1, 2, and 3. Write 3 ratios that are equal to the given ratio, kind of like the example above there. And then 4 and 5, tell if each pair of ratios is proportional. So you're going to go through the steps on page 302 to the left there, and bring it to class tomorrow with a question. See you then.